All right, taking a look at a video this time dealing with some algebra topics. In particular, we're going to deal with like terms and what are like terms, how do they work, and then we're going to take a look at the concept of distribution, putting these together. This is an expression situation. We're going to be simplifying, we're not going to be solving, so we'll be going in the correct order of operations. So we're going to go through the concept of like terms, then we're going to go talk about specifically what it looks like from an algebra standpoint, and then we're going to take a look at the concept of distribution, and then we'll take a look finally at distribution from an algebra standpoint. Okay, so let's dig right in. The concept of like terms is a really very simple type thing. If I had 3 apples and 2 computers, those are not like things, so we don't add them together, okay? But if I went in my refrigerator and I found 6 more apples and for some silly reason another computer, then I can now begin to combine things. This is what like terms is doing. What are the things that are alike so that I can be able to combine them together? This is an adding and subtracting thing, so it's fairly simple. So I take the things that are alike. I have 3 apples. I add together 6 apples. That means I have a total of 9 apples. I didn't use oranges here on purpose because it's fruit. We're going to stay specifically with what we've got. 2 computers plus 1 computer means I have 3 computers. All right. Let's give you another situation. This is actually one that I run into on a fairly consistent basis when I'm building stuff. If I had, say, one board that was 6 feet and then 7 inches, and I'm spelling them out like this. You don't normally need to do that. And then I wanted to, for whatever reason, add on another 2 feet and 3 more inches for another board. In that case, then I could begin to combine the things that are alike. Yes, I can convert inches into feet and feet into inches. At the same time, I can also just leave it in this situation, which mirrors the idea of what we're doing with like terms. So together we would have 8 feet and 10 inches. Okay? Probably a little bit more realistic situation. Again, just dealing with the same type of thing, just real quick, just trying to set in your head what like terms is doing. Let's say I had that same 6-foot, 7-inch board, that's just the notation for it, and I wanted to subtract cut off a piece that was 4 feet, 5 inches. All right, what would be left? 6 minus 4 makes 2 feet, 7 minus 5 would make 2 inches. That's the idea of like terms. Like terms are the things that come from stuff that is matching. All right, so keep that in mind. Just because we turn it into algebra and begin to add in variables and that sort of thing doesn't really change anything in what's going on. It's the same concept of what it is that needs to happen. Okay, so when you work through in the same way that you work with inches and feet like I was doing here, or apples and computers in my silly example there, nothing changes if we add in things that have to do with variables. Okay, so say for example I had 7x plus 5. There's nothing specifically given, but the 7x and the 5 are not the same thing. This could be 7 feet, 5 inches, or 7 apples and 5 computers, or whatever the case is. These are not alike because they're differing with one another. So these don't combine. All right? And if I want to add to that 11 more x and 2 more, whatever the other things are, this is the same thing as the apples, the computers, the inches, and the feet. Nothing changes in what's happening there. The things that are alike go together. So the 7x plus the 11x makes 18 x's, whatever x's are, and then the 5 and the 2 make the 7. All right? This is the process of simplification. What I did is I simplified the expression to go from one place to the next place. All right? Now, there's a way to check this. There's a way to be able to go through and know whether what it is that I've done is correct. And that's an expectation that I have. Not all your teachers are going to have that, but it's something that you just need to be aware. This is also really good for like a standardized test or something like that. There's a way to be able to know if what the work you've done is correct. In this case, I'm going to plug a 3 into both of them. So in this case, I'm just going to do all this in my head real quick. That's 21 plus 5 plus 33 plus 2. So that's 54 plus 7, so this turns out to be 61. If I plug a 3 in there, 18 times 3 plus 7, 18 times 3, that's 30 plus 24, which is 54, plus 7, which is 61. That lets me know I most likely have done my work correct. That's the checking process, okay? This is the actual work. If you're asking for a quote-unquote answer or solution or simplified form, that would be the answer. This is the checking process. Get used to doing it when things are easy so that it becomes a natural habit when things, maybe aren't quite so easy down the road. All right, let's take a look at another example. Let's say, for example, we had 13x squared minus 6x plus 4. Boy, that's an awful lot of mess. And let's say we're going to subtract 8x squared, add 4x, and subtract 11. What do we turn out as? Well, we combine the things that are alike. The x squareds are things that are alike. That's where the term like terms comes from. 13 minus 8 is 5x squareds, whatever x squareds are. Let's say that's square feet, or maybe it's oranges, or maybe it's couches. I don't know what it is, but the x squareds are the things that are alike. Okay, that x squared is just like whatever you want to fill in there. Cabinets, tables, feet, inches, miles, meters, whatever it happens to be. All right, 6x and 4x are the things that are alike. Negative 6 plus 4 is negative 2x's, and those don't combine. Yes, they both have x's, but this one is an x squared. Don't let the exponent fool you. They need to be exactly the same in order for you to put them together. All right, 4 minus 11 is negative 7. All right, so this is my simplified version of what's going on there. Let's do a quick check. So let's plug in a 3. So that's going to be 13 times 9. And 3 squared is 9, so that's going to be 90 plus 27, so that's 117. Minus 18 plus 4 minus 8 times 9, which is 72. Plus 4 times 3, which is 12, minus 11. 117 minus 18 is 99. That's 103. Let's see, 103 minus 72, that's going to be 31. Plus 12, which is 43. Minus 11, which is going to be 32. Hopefully I did all that right in my head. Plugging a 3 into the other one, that's going to be 5 times 9, which is 45. Minus 6 minus 7. 45 minus 6 is 39, minus 7 is 32. And there's my match that I'm looking for as I go through there. Yes, by all means, do your calculator. Yes, I did do that in my head. You don't have to do that. Make sure that you can do that work in your calculator. It's a piece of cake calculation. Real quick to plug into your calculator. That way, when you turn in your test or your quiz or whatever it happens to be, you know for a fact that you got your answers right. All right, in the same vein or along the same lines, we have this concept or this idea of distribution. It's very, very similar to the simplification process and the work that we're doing here with like terms. Now we're just doing something just totally different. It's still working with expressions, but let's first of all take a look at the concept. If I had 5, for whatever reason, 5 times 7 plus, let's say, 8, all right? In this situation, is it 5 times 7, is it 5 times 8, or is it 5 times what? Well, following your order of operations, you know in your head this is supposed to be 5 times 15. And that 5 times 15 is going to be 50 plus 25, so that turns out to be 75. All right? Is there another way to arrive at that 75? And the only reason I'm showing you this is not the way I would expect you to do the problem, but is there another way to get to that 75? Because that's the principle behind distribution. And the answer to that question is yes. It's not just 5 times 7. It's 5 times all of this. That all of this turned into the 15 in one case, but there is another way to do that. You can be able to say 5 times 7 and 5 times 8. That's the distribution process. Distribution means to take the outside value you're multiplying by and distribute it into the parentheses. So in this case, I end up with 35 plus 40, which turns out to be 75. Now normally I would not do a problem this way, but what this is doing is illustrating what it is that we're going to show you here in just a second. The key here is this. Keep in mind it's 5 times all of this. That's the biggest thing students get confused about. They want to just do the 5 times the 7 and then the 8's just along for the ride. Don't do that. This parentheses means it's 5 times this. It's 5 times all of this, not just 5 times the 7 or 5 times the 8. It's 5 times the 7 and 5 times the 8 because those things have to go together. All right? So don't make that common mistake that a lot of students make. All right? So now let's take a look at the same concept from an algebra standpoint. That's the basis behind it. Now let's take a look at what it actually is going to look like. So let's take the same concept or the same idea. So let's say we have 5 times x plus 3. Is it just 5 times the x? Is it just 5 times the 3? No. It's 5 times all of this. Now you can't combine the x and the 3 together like we did on the last screen. So it's got to be 5 times both of these in order to distribute or simplify. 5 times x is 5x, because this x technically has a 1 in the front of it. All right? 5 times 1 produces the 5. 5 times 3 produces 15. Now I'm confused. Did I do it the right way? I'm not really sure. Hey, check it. I check it by plugging in the 3. 5 times 3 plus 3 doesn't have to be a 3, by the way, but that's what I tend to use. That's going to be 5 times 6. That produces 30. 3 in the answer makes 5 times 3 plus 15. That's 15 plus 15, which is 30. It works out just fine. Okay? Let's take a look at one more example here. We'll go a little bit more complicated, but the process is the same. Nothing really changes. All right? Just going to show you a couple of different things through this extra example here. So we're going to do 11 times, we're going to go 2x squared minus 6x plus 3. Oh my gosh, no it's not. It's 11 times all this. Not just 11 times the first one, it's 11 times the parentheses. All of it. That's got to distribute into all the pieces. Don't just remember just distribute. It's 11 times all of this. That means all these pieces have to deal with the 11. 11 times 2x squared, the 2 times 11 produces 22. 11 times 6, negative 6 is negative 66x. And 11 times 3 produces the 33. Okay? So that process is not just the 11 times the 2x. The 11 times the 2x, the negative 6x, and the 3 that produces these pieces that are here. All right? By all means, use a calculator to be able to go through and check what it is that you need to do. Here in this case, this time instead of using a 3, I'm going to use a 2 because it's a little bit smaller number. These things are going to get big pretty fast. So this is going to be 11 times, let's see, 2 squared is 4, so that's going to be 8 minus 12 plus 3. So that's 11 times negative 4 plus 3, which is negative 1. This is supposed to turn out to be negative 11. All right? Let's see what happens in the bottom. That's going to be 22 times 4 minus 66 times 2. Well, that's going to be a lovely question. Plus 33. Let's see what we earn. Let's see what we turn out with. This is going to be 88 minus, let's see, that's 120 plus 12, 132 plus 33. Well, I'll do that one first because that's pretty easy. 88 minus negative 32 plus 33 is negative 99. 88 minus 99 is negative 11. Looky there. My check works out. All right, so this video was dealing with 2 expression concepts. One is called like terms, where you're combining things that go together, adding, subtracting only. Multiplication is a whole different ballgame. And then distribution. The biggest thing on distribution is just remembering that whatever you're distributing into the parentheses goes into all the things in the parentheses. It's not this times the first thing, or this times the last thing, or this times the middle thing. It's this times all of this. So all of these pieces have to get a piece of that pie of what's up there. Okay? If you have any questions or you're confused about anything, make sure you talk to your teacher. They should be able to help you out and give you some specific guidance on anything that you might be confused about. Until next time, see ya!